All right, this is the 6th FRQ for the 2017 AB exam. So they give you a table with g of x and g prime of x, they give you a graph of h of x, and they give you an equation of f of x. So lots of things going on here. First, they said to find the slope of the tangent line to the graph of f at x equals pi. So that means we need to find the derivative of f and then evaluate it for pi. So f of x is cos 2x plus e to the sine x. And so the derivative of cos is negative sine. So we've got negative sine, keep the inside the same, and then multiply by the derivative of the inside. And then the derivative of e to the x is just e, keep the inside the same, multiply by the derivative of the inside. And so now what I'm going to do is just plug in pi. All right, so sine of 2 pi is 0. So I've got negative 0 times 2, which is just 0. Sine of pi is 0, so I've got e to the 0, which is 1. And then cos of pi is negative 1. So the derivative evaluated at pi equals negative 1. All right, part B says let k be h of f of x. All right, so for me to find k prime of pi, that means I need to find the derivative. So I've got the derivative of the outside, keep the inside the same, because we're doing the chain rule, multiplied by the derivative of the inside. So we have h prime f of pi times f prime of pi. F of pi is cos 2 pi plus e to the sine of pi. So cos of 2 pi is 1. Sine of pi is 0, e to the 0 is 1. So this means that f of pi is 2. Okay, so k prime of pi is h prime of 2 times f prime of pi is negative 1. H prime of 2 is saying, look at the graph of h of 2 and then tell me what the slope is right there. And the slope is down 1, right 3. So I'm going to have negative 1/3 times negative 1, which is 1/3. All right, next we have m of x is g of negative 2x multiplied by h of x. So, and they want us to find the derivative at 2. So this is going to be a product rule. So I've got the first times the derivative of the second plus the second times the derivative of the first. That's a chain rule, so I did the derivative of the outside, kept the inside the same, multiply by the derivative of the inside. So now I can go ahead and plug in 2. So I've got g of negative 4, h prime of 2, h of 2, g prime of negative 4, negative 2. So g of negative 4 is 5. G prime of negative 4 is negative 1. So 5 times something, something, negative 1, negative 2. Okay. H of 2, if this goes down 1 over 3, then it goes down 1/3, down 1/3, down 1/3. So this y coordinate should be negative 2/3. So h of 2 is negative 2/3. H prime of 2 is negative 1/3. Now, if you want to leave it there, you can, but I'll say this is negative 5/3. Negative 2 times 1 times 2 is negative 4/3. Negative 9/3, negative 3. All right, and then for part D, it says, is there a number on the interval such that g prime of c is negative 4? For these problems, we're typically going to use the numbers of the interval themselves, and this is g prime, so this is the mean value theorem. So I'm going to look for the slope. So I'm going to say g of negative 5 minus g of negative 3 over negative 5 minus negative 3. G of negative 5 is 10 minus 2 over negative 2. All right, so before I use the mean value theorem, I do have to be able to say that g of x is continuous, and g of x has to be continuous because it is differentiable, so you are able to take a derivative. So I'm going to say g of x is differentiable and continuous, and therefore continuous, on negative 5, negative 3. And then I'll say by the mean value theorem, there exists some c on negative 5, negative 3 such that g prime of c equals negative 4.